This section takes up the topic of variation within a distribution, which is the V in the 5 characteristics that we talked about. Different distributions may have the same mean, but widely different variations. There are 3 different measures of variation: range, standard deviation, and variance. Range is the difference between the maximum and minimum values. Standard deviation is a measure of variation of values about the mean. And variance is a measure of variation equal to the square of the standard deviation. So once we know the standard deviation, all we have to do is square it and we'll get the variance. Or if we're given the variance, take the square root and you'll have the standard deviation. So when rounding measures of variation, make sure you carry one more decimal place than what's present in the original set of data, and do not round until your final answer. So range. We have 5 students, test grades. Find the range. To find the range, we take the maximum value, which is a 95, and subtract the minimum value, which is a 52. And 95 minus 52 is 43. Now, standard deviation. The standard deviation, S, of a set of sample values is a measure of variation of values about the mean. The standard deviation will always be a positive value or 0, never negative. Generally, standard deviation is the most important and useful measure of variation. The value of the standard deviation S can increase dramatically with the inclusion of one or more outliers. The units of the standard deviation S are the same as the units of the original data values. Population standard deviation is denoted by sigma. So, standard deviation, sample standard deviation, is denoted by S, and on your calculator it'll be a capital SX. And then population standard deviation is denoted by sigma, and on the calculator it'll say sigma x for population. When thinking about standard deviation, think distance from the mean. Just like absolute value represents the distance a number is from 0, standard deviation represents the distance a number is from the mean. So, drawing just within this, if you have the absolute value of a number, and say the absolute value of 15, that's 15, correct? Absolute value is always positive. Standard deviation is always positive. But if you have an absolute value of 15, you don't know whether you're negative 15 units or positive 15 units. If you're just told that the absolute value is 15, you don't know if you're above or below the mean. It could be both. Same with standard deviation. Sorry, absolute value above or below 0. Standard deviation would be, are you above or below the mean? On the variance of a set of values is a measure of variation equal to the square of the standard deviation. It has the disadvantage of having different units from the different values, and thus is more difficult to interpret. Different units from the data values, and thus is more difficult to interpret. The sample variance is denoted by S squared. The population variance is denoted by sigma squared. So, sample standard deviation was S. To find variance, square it. Population standard deviation was sigma. To find the variance of the population, square it. So, let me tell you a little example here. Say you use your calculator to find your standard deviation, and it said S of x is equal to 1.71526873. And the question was, what is the variance? You would have to take, to find that variance, S squared, you need to take all those decimal places. It's one of those cases where you do not round until your final answer. all those decimal places, square them, and then you can round to one more decimal place than what was in the original data set to give your variance. We will use the calculator to find standard deviation and variance. We will not use the formulas. If you watch a video or look at an example where it's telling you to use the formulas, ignore what it's telling you to use and use what I have told you to use, which is the calculator, and we will discuss those in the next topic.